Hello everyone and welcome back to our DBMS revision series. आज हम DBMS का एक बहुत important topic समझेंगे जो exam और interviews दोनों के लिए बहुत important है. We're talking about isolation levels. You know, if you're preparing for your SPPU MCA exams, this is literally one of those guaranteed topics that professors absolutely love to ask about. So, get ready. Grab a pen if you need to, because by the end of this revision session, your concepts are going to be crystal clear. Let's dive right in. Now, before we just jump straight into textbook definitions, let's understand the core problem first. Like, why do we even need isolation in database management systems in the first place? Just think about it. सोचो क्या होगा अगर thousands of concurrent users एक ही time पर exactly same IRCTC railway ticket book करने की कोशिश करें? Or what if you and your friend are using Google Pay simultaneously to transfer money from the exact same joint bank account? Without strict rules in place, the database would become a complete disaster. Money might get deducted twice or a single seat might get double booked. Basically, isolation is the magic shield that prevents all this back-end chaos. Here's our quick roadmap for today. First, we'll do a quick introduction to isolation levels. Then we'll climb the ladder of strictness, starting from read uncommitted, moving up to read committed, then repeatable read, and finally, the serializable level. And, of course, we'll wrap up with some crucial exam tips and a summary. All right, Section 1. Let's start with a quick introduction to isolation levels and concurrent transactions. So, isolation basically ensures that concurrent transactions don't interfere with each other. But here's why that actually matters. Let's walk through a very practical banking scenario step by step. Imagine step 1, user A checks their balance at an ATM. The database says they have 10,000 rupees. Okay, then exactly 1 millisecond later in step 2, user B deducts 5,000 rupees via GPay from that exact same account. But wait, before user B's transaction is fully saved, or in DBMS terms, before it's committed, step 3 happens, a massive system crash. Now, if user A's transaction somehow read that intermediate, unsaved data, we're looking at a huge data mismatch. Isolation levels dictate exactly how a database handles this kind of scary overlap. Moving on to Section 2, read uncommitted. This is the lowest rung on our isolation ladder. At this lowest level, you've got extremely high database speed, but honestly, data safety is practically zero. By definition, read uncommitted allows a transaction to read uncommitted data from another concurrent transaction. Think of it like this. Imagine you were saying your friend's GPay transfer processing on their screen, and you assume the money is already in your account, but the bank hasn't actually finalized or committed it yet. If their payment suddenly fails, the money you thought you had just vanish. You basically read data that was never made permanent. Now, pay really close attention here, guys, because exam point of view se ye bahut important hai. As a professor checking your paper, I am specifically looking for one keyword here. You must always mention the dirty read anomaly when you explain read uncommitted. Reading halfway done unfinished data, that's called a dirty read. Seriously, if you don't try dirty read in this section, you are going to lose marks. Mark this as absolutely crucial for your exams. Next up is Section 3, read committed. Let's see how we fix those dirty reads. Let's step up the safety a bit. Under the read committed level, a transaction can only read data that has been fully committed and saved by other transactions. जब तक transaction properly save नहीं होता, कोई दूसरा user उसको read नहीं कर सकता. It's that simple. This completely prevents the dirty read anomaly we just talked about. You will only ever see finalized ATM transactions, never the halfway done ones. Fun fact, this is actually the default isolation level for many popular databases out there, because it offers a really solid balance. But the crucial point for your exam is understanding the trade-off here. Let's compare them directly. Read uncommitted suffers from dirty reads. Read committed successfully prevents those dirty reads, but wait, it allows a brand new problem called non-repeatable reads. So what does that mean? Well, imagine you're shopping on Amazon during the big billion days. You read the price of a phone and it says 20,000 rupees. Great. You go to checkout, but in that exact split second, another transaction commits a price update. You refresh the page and boom, now the price is 22,000. You read the exact same data twice within your session, but got two completely different, validly committed values. That right there is a non-repeatable read. All right, Section 4, repeatable read. This is where we secure your session by locking the data view. Repeatable read ensures that if a transaction reads data multiple times, it will see the exact same value every single time, no matter what other users are doing in the background. It basically locks the data you are looking at. So if you check your ATM balance and it says 10,000 rupees, it locks that view for you. Even if a recurring bill auto-deducts money halfway through your session, your screen won't mysteriously change until you actually finish your current transaction. एक बार read किया तो value same ही रहेगी. And here comes your next big exam tip. Examiners love to test if you know the limits of this specific level. Yes, repeatable reads stops non-repeatable reads perfectly, but you have to watch out for something called phantom reads. So a phantom read happens when you run a query to count multiple rows, like, say, counting total employees in a department. Because you didn't lock the entire table, another transaction can sneak in and add a new employee. The existing employees didn't change, but suddenly a new phantom row magically appears in your count. Moving on to Section 5, the serializable level, the strictest, most secure level of them all. To stop those phantom ghosts from appearing, we bring in the ultimate boss of isolation. At the serializable level, transactions are executed sequentially. That means one after the other, ensuring complete, perfect isolation. Imagine taking a chaotic crowd at an ATM and replacing it with a single, strictly enforced line. Person A does their complete transaction, then person B goes, then person C. Ik ke baad ik. There is absolutely zero overlap. And because everything happens sequentially, there are no dirty reads, no non-repeatable reads, and absolutely no phantom reads. It's completely foolproof. But come on, nothing in engineering ever comes for free, right? Look at this trade-off, because this is exactly what your professors will test you on. The serializable level gives you perfect banking accuracy, sure, but it results in very, very slow performance. You're basically forcing a powerful system that can handle thousands of concurrent tasks to do them all one by one. In contrast, the lower isolation levels offer incredibly fast performance, but as we saw, they are prone to data anomalies. So you always have to choose what your application needs more, perfect safety or high speed. Finally, Section 6, exam tips, and a quick summary so you can lock in those SPPU marks. Okay, take a deep breath. You've successfully climbed the entire isolation ladder. Now, I want you to memorize the matrix you're seeing right now. This is your golden ticket. If you get a question on isolation levels, drawing this exact table in your exam is going to guarantee you excellent marks. Let's read it together real quick. Read uncommitted, all three anomalies are possible. Read committed, dirty read is prevented. Repeatable read, dirty and non-repeatable are prevented. And serializable, all three anomalies are totally prevented. Examiners look for this specific matrix to instantly know that you understand the core concepts. Ye table exam mein draw karke aana, full marks pakke milenge. So, just to sum up the big picture takeaways here. First, isolation stops concurrent transaction chaos. It's what keeps our digital lives running smoothly. Second, climbing the levels from uncommitted all the way up to serializable adds more and more database safety by eliminating anomalies step by step. And third, the golden rule of databases. Stricter isolation severely slows down your system's performance. I leave you with this final, kind of provocative thought. With modern databases handling millions of rapid transactions every single second, for apps like Swiggy, Zomato, and UPI, is serializable isolation actually dead in the real world? Just think about it. Can we really afford to put everything in a single line anymore? It's a great concept to ponder as you master DBMS. Agar ye explainer helpful laga ho, to like, share, and subscribe zarur karna. Best of luck with your SPPU exams and keep learning.